Okay, we're starting Chapter 2, which deals with equations, inequalities, and problem solving. This first section I think is pretty easy, where we will be simplifying algebraic expressions. And we'll refer to what expressions are shortly too, but we're going to identify the word term, like terms, and unlike terms. Now in this particular column, all of these items are a term. Now a term by definition is something that's in between usually a negative and a positive sign. And we'll see that when we go over some algebraic expressions. But within a term, you have in algebra a variable, which is a letter or letters. But then there's something that goes with the variable or letter, and that's called a numerical coefficient. And that's what they're asking us to identify here. What is the numerical coefficients of these terms? Well, it's basically the number that is with the term. So here it's a 3. Now, the number with this term, up in the numerator, there's a 1 there that we don't write usually. And then in the denominator, we have a 5. So the numerical coefficient of this term is 1/5. And this is another way to write it. The numerical coefficient of this term would be 0.7. Now, as we mentioned in earlier lessons, with every number, there is a 1 above it, and as well as a 1 below it. We don't write that one, and we usually don't write that one either. But the numerical coefficient of a term, which is just a letter, would be a 1. Now here, in the case we have a negative y, what would be the numerical coefficient of that? Well, a negative 1. And since there is no variable, the numerical coefficient of this is just the negative 5. So each of these are terms, and we've identified the numerical coefficient. In example 1, then, we're asked to find the numerical coefficient. So it would be the numerical part, negative 3, 22. No number before it, there's a 1 there. No number before it, there's a negative 1 there. And there's a 1 there, so this would be 1/7. We include what's in the denominator. Okay, now we're asked to identify what are like terms and unlike terms. Well, by definition, a like term has exactly, or very, very close to exactly, the same variables to the same degree. So these have the same variables and the degree is 1. Now these are unlike terms because here the variable is to the first degree, this is to the second degree. They're not the same, so they are unlike terms. Here we're identifying the variable part, x squared y, x squared y, x squared y, exactly the same. We don't care about the numerical coefficients at this time. We're just interested in identifying if they're like terms or not. So here, these have xy, but they're to different degrees, different powers. So these are not like terms. Here, our variable is ab squared c cubed. ab squared c cubed, these are like terms. Now here, this has ab, but this one is a c cubed, this one doesn't have it. So again, like terms, unlike terms. Like terms have exactly the same variable. Now, when I said this before, let me go over this. That if you have something like AB and BA, these would be like terms, but are they exactly the same? Well, no, but because of the commutative property, we know they can switch around. So even though the letters aren't in alphabetical order here, we try to keep them in alphabetical order. These would be like terms. So here we're asked, are these like terms? Well, we're identifying the variables. Do they have exactly the same variable to the power? No. Yes. Oh, there's one more too. There you go. Now here's where we told you we have yz and zy. Are these like terms? Order is not critical, it's the exponents on the variables. Okay. As we move along, we're going now into combining like terms. Now here, we're going to identify, first of all, are they like terms? And if they are, then we deal with the numerical coefficient and do what they've asked. So here, we're asked to subtract a 3x from a 7x. So 7 minus 3 gives us a 4x. Here we're asked to add a 10 and a 1. I have to remember the 1 is there. This will become an 11y squared. Now here this is a little tricky because the only like terms here are this and this. This is not a like term because it's x to the second. So this part stays the same, x squared. And then we're going to subtract a negative 3 from a 2, which will leave us with a negative x. A 1 should go there, or goes there, but we don't write it. And then in this one, again, you can do it a couple of ways, thinking what we did before. Remember, there's a 1 there. This would become a 10 minus 5 is going to be 5n squared. Or you could have done it this way, got a 4n squared, add a 1 to it, it gives you the same answer. It just makes the calculation a little easier. Continuing to combine like terms, there are a couple of techniques here you might want to look at. First, what are the like terms? And I suggest to my students just indicate what are like terms. Now, you'll notice here there are no like terms. You can't do anything with that. And these are both like terms. Okay. So then we're asked to combine like terms. Well, 2x plus 3x is 5x. 5 plus 2, 7. Now here, where there's no numerical coefficient, remember there is a 1. So a negative 5 and a positive 1 will give you a negative 4a. Negative 3 plus 2 is a negative 1. And you'll have practice to be sure to hone your skills. Here, this is the answer. There's no like terms. You can't combine anything. Now here you have to be careful of the decimal, but this is just going to be 7.3x, 5 and a 2.3, and then a negative 6. Now, in order to combine these two terms, we have to have that 1 in the form of 2 over 2. Now you have common denominators, so there will be a b in the answer, and you have a negative 1/2 plus 2 over 2 gives you a positive 1/2. Now as we move on this, you'll see that we're building up to do some real algebra. This is like beginnings, things that we learned just recently we're going to apply now. So here they want us to remove the parenthesis through distribution. So 15x plus 10. And again, mentally be thinking you're going to multiply each term. And a term, we said, is separated by either a positive or a negative sign. And you have to watch the signs. So a negative 2y, a negative 0.6z, and a plus 2. Watching the signs carefully. Now here's something, again, we mentioned it in the last topic, but when there's a negative in front of a parenthesis, you can get rid of the parenthesis just by changing all the inner signs. I had someone today that was doing this, and they changed everything but the first one. Ooh, and they ended up with the wrong answer. So this will become a negative 9x, a negative y, a positive 2z, and a negative 6. A very useful thing. And if you wanted to change all these signs, you would do so by taking out a negative 1, putting everything in a parenthesis, and then putting that negative outside. We were building up to this now. It's part of our title, Simplifying Algebraic Expressions. And now they're asking us to simplify algebraic expressions. It often involves first removing parentheses, then combining like terms. So, first thing we're going to do is remove parentheses. 6x minus 15 plus 1. And now we can combine that into 6x minus 14. Here we're going to distribute, and this gives us a negative 8x minus 14. Here we're just going to get rid of the parentheses by changing both signs. This will become a negative 3x and plus 1. So our like terms now, these two, give us a negative 11x minus 13. Here we have a 9 plus 12x minus 30. Combining like terms, we get 12x minus 21. And it never hurts to check your work. This next example is going to be very important in understanding your knowledge from English to algebra. And here for example 7, it says subtract this from that. So if you could remember this is super important. When they say subtract, another way of thinking of this is put it in parentheses and put that negative sign there to indicate subtraction. So this now becomes a negative 4x plus 2, and then we just write this out. So this is what we originally had. We want to subtract this, and by putting a negative, put this in parentheses, then we just change these signs and combine like terms. And there is your answer. Now another way of thinking of this is if it's set up this way, you'll see this a little later. 2x minus 3 minus 4x minus 2, and that's in parentheses. So you're subtracting this from this. If you see something like that, my strong suggestion is you take away the parentheses. This was a negative, I'm sorry, was a positive. Now it becomes a negative, this becomes a positive, and you're just adding them up. And you get the same thing. This is the last section of 2.1, and we're writing word phases into algebraic expressions. So we're converting English into algebra. Twice a number plus 6. Well, twice a number plus 6. The difference of a number and 4. Well, that's going to be a number minus 4. Now that's the difference, and this is to be divided by 7. So we're going to use the division bar for a grouping symbol because this difference is divided by 7. Now that's critical. Or you could put this in parentheses also and divided by 7. 5 added to triple the sum of a number and 1. Well, what's the sum of a number and 1? Now what are we going to do to that? We're going to triple it. So we multiply by 3. And we're going to do what to that? Add 5. Now, that's how it would look. If we were to simplify that, we'd then have to distribute that, and that would be 3n plus 3 plus 5, and then eventually we would get 3n plus 8. So this would be the statement. That's what we have here. And if we were to simplify it, we'd have to get rid of our parenthesis, and we'd end up with that. Now here they're asking for the sum of twice a number, 3 times a number, and 5 times a number. Well, twice a number is 2n, 3 times a number, 3n, 5 times a number, 5n, and they're asking for a sum of that. So all of that together, since they're like terms, would be 10n. Okay, you're going to have plenty of practice, and again, depending where you are, You could skip the practice, go directly to the quiz-mes, earn your mastery as you start on your journey to eventually equations, inequalities, and problem solving.